Dear students, welcome to the practical computing class, and today we have our fourth lecture. So the title of this lecture is Conditional Functions. So please check out what is the meaning of conditional functions. First of all, of course, you need to understand what is condition, okay? And second one is function, right? You know, function is hamsu in Korean language. So, first of all, dear students, I would like to inspire you with the following quotation of Bill Gates, who said that the computer was born to solve problems which did not exist before. So by using computers, we solve new problems. We create new problems. So the learning objectives are shown here. First, I will discuss logical comparison operators. So let me clarify it here. So first of all, you need to understand what is logic, right? Logic. Logic. So I will talk about logical comparison. So comparison comes from comparing, compare, right? Operator. A logical comparison operator. I think, yes, you can find some useful words here. So then we will continue with Boolean functions. Boolean functions. Boolean functions, I think is the pronunciation is similar. You know what is a function, and please check out what is Boolean here. So then I will talk about table lookup functions. Table lookup functions are very useful if you work with large tables and if you are looking for some information in these tables. So then I will talk about conditional arithmetic. Conditional arithmetic. Conditional arithmetic, and then conditional formatting for data visualization. Again, here is important to understand what is condition and what is conditional. So first of all, dear students, before you continue to watch this lecture, I suggest you to study the glossary which we work on every week. So this is very important. So if you don't understand the terminology, if you don't understand these terms which are extracted from this lecture and from the textbook, this is your textbook. So today we work on conditional functions, and you can find this in chapter number 5. So you can look here, chapter number 5, conditional functions. So the most important words or terms, I think you know what is a terminology. So most important words were extracted from this textbook and from also from my presentation. So my presentations are mostly based on this textbook. So you can find many things which were taken from this textbook. I already told you this. So please stop this video and first of all study the terminology. So that would be a more efficient way of learning this class. So logical comparison operators, also in computer programming, they are known as relational operators, are used to make tests or to establish a criterion. So if you don't understand what is criterion, so please check it out here. So when studying logical comparison operators, we will concentrate on numerical comparisons, such as is the value in cell A1 greater than 4? So we will store some number in cell A1, and we will check if this value is greater. Greater means larger than 4. So I suggest us to check a very simple example is discussed on the next page of this presentation. So first of all, I would like to give you a list of the comparison operators. So they are as follows. So the first one is known as equal to. I think in the field of mathematics, you always use such kind of operators, if you of course remember. So we have such expressions. We write x is equal to 5, for example, right? Or 5 is equal to 5, right? So equal to. So it's called equal to. The next one, the next operator is called greater than. Greater than. Instead of larger than, we say greater than. So obviously 5 is greater than 1, right? So this is true, right? True. But if you say 1 is larger than 3, right? So this would be wrong, right? Wrong. Or we can conclude that this is false, okay? False. So the next operator, so here, near to greater than, we add equal sign here, equal. So equal sign should be added on the right. So you'll write in this way, greater or equal. So equal is always on the right. So we read this as greater than or equal to. The next operator is a less than. So 1 is less than 2, right? So this is a true statement. True. True, right? But if you write something like 0 is greater than 1, right? So this is wrong, right? You can say that this is false. False. I hope you understand the meaning of true and false. I think in the glossary you have already translated these terms. The next term is, the next operator is less than or equal to. Less than or equal to. So don't forget, so equal is always on the right, as here, right? Equal sign is always on the right, so you cannot put it on the left. And the next one is not equal to, right? Not equal to. So one example, let's say, usually in maths we use another term, another operator. We usually write equal, right, and use this line, so which says that is not equal. So obviously 1 is not equal to 2, right? 1 is not equal to 2. But in programming languages and also in Microsoft Excel, we don't have such kind of symbol. So instead of this, we use these two actually symbols, which is mean not equal to. Okay, so I hope you understand these comparison operators. So, or you can say a logical comparison operator. So the translation is somewhere here. Okay, now let's return to the example. Actually, a very simple example. First of all, you need to understand the example itself. I think also sometimes in your homework, you solve various problems from your textbook. So in textbook, of course, they first of all explain what is the problem, so you need to clearly understand it. So if you don't understand it, if you don't understand the English language, then you cannot solve this problem. So let A1, so A1 is a cell A1. Cell A1, so where is cell A1? I will show you where is cell A1. This is cell A1, okay? So the address of this cell is column A intersecting row 1, right? This is cell A1. So let A1 hold the value of 10. So we need to use value of 10 in cell A1. Okay, I'll type 10. I will center it, I think. Okay. And cell B1 has the formula. The formula is starting from the equal sign, as you already know. So if you don't use equal sign, then you cannot compute it, right? It will be considered as just a text or some general input. So first of all, we have to write equal sign. So then A1, right? A1 is cell A1. Then we use comparison operator. So how do we read this comparison operator? So if you do not forget, then you can, of course, directly say greater than. So if you forgot, you can return to the previous slide and check it out here. Greater than is shown here. So A1 greater than 10. So now let's type this formula. I'll return here. Again, we start with equal sign. Equal. So A1, right, is a reference to a cell. So you can select it, or you can simply type by using your keyword. Unfortunately, here I cannot show you what kind of keys I'm pushing on my keyboard. Okay, so I will select it directly. So A1. Okay, now you can see it here. A1. Then what? Greater than what? Greater than 10, right? Greater than 10. I will type 10 here. Enter. So what do we have now? So we want to check if cell A1, right, is greater than 10. So basically, what do we have here? We have 10 in the cell A1, right? Let's say I want to check if 10 is greater than 10, right? So if your, for example, math teacher in your school will write such kind of statement, of course it will be very strange for you. I mean, what is the meaning of comparing 10 and 10? This is just an example. So, of course, we know that 10 is equal to 10, right? 10 is not equal to 11, 10 is not equal to 12, but 10 is only equal to 10. So this statement is true, right? True. Or correct, right? Usually we can say correct, right? Correct. Correct. But in Excel we use true, right? And so this statement is what? Is false. False. Or in real life we use wrong, right? So this statement is wrong. Why? Because 10 is not greater than 10. 10 is equal to 10. So as a result, Excel also, and so actually this logical comparison returns false here. Returns false. We can modify cell A1. For example, instead of 10, I can use what? I can use 1. Let's say 1. Okay, the answer is still false. Why? Why? Because I'm comparing 1, right? I'm comparing 1 and to 10, right? So obviously 1 is not greater than 10. This is a false statement, false. Why? Because 1 is less than 10, in fact, right? So if you say 1 is less than 10, then it will be true, right? True. or correct. This is wrong. So now let's modify the input. Let's modify the input. Instead of 1, let me use 11. And let's see how actually A2 will change. Okay, so if we have 11 here, so then A2 turns through. So we compare 11 with 10, right? So 11 is greater than 10. So this is true, right? We cannot say that this is false. This is a true statement. That's why Excel returns true here. So now let's modify the input. Instead of some number, let's use some text. So let's compare Tegu with 10. What happens? Something strange happens, right? Something strange. You compare Tegu and what? With 10, right? Tegu is larger than 10. So how do we compare Tegu with 10? It's kind of very strange comparison, right? So you cannot compare apple with a number, right? You cannot compare building with apple. It has no meaning. So this has no meaning. No meaning. But here, so Excel returns true. So which is a big question. So dear students, whenever you compute something, you need to firstly think by using your own brain. So do not always rely on computer, because if you do not explain something actually precisely to computer, it can make some mistakes. This is one of such examples. So you need to be very careful. So, dear students, if you write something like shown here, A1 is greater than 10, or you can use any other logical operator shown here, so then you can call this as a logical expression. Okay, this is logical expression. So now let's simply modify this example, and instead of greater here, I'll use another comparison operator, which is known as greater than or equal to. Greater than or equal to. Instead of A1 greater than 10, I'll write A1 greater than or equal to 10. And let's see how it will influence on the result. Okay, so I have 10 here. 10 is greater than 10 returns false. So now let me modify it. So instead of using greater, I will use equal. Okay, so here, don't confuse, we have two equal signs. The first equal sign tells us that we start a formula, right? Or we start some computations. And this one is related to greater or equal to. So at the end, you will press Enter button, and you will see that something has been changed, right? So instead of false, we have true. So the question why it happens. Okay, so let me write it here using just some numbers. 10 greater, or so in maths we usually use it this way, right? Equal to 10, right? So it means greater or equal. So this is in Excel, right? Excel. So if I write in this way, greater or equal, 10 is not greater than 10, but 10 is equal to 10. So we can say that this is a true statement, right? True statement. So that's why here Excel returns true, right? So don't forget, we have many more logical statements. And for example, another statement, let's say I'll use here not equal. I need to use this one and this one, okay? It means not equal. Okay, enter. Okay, so 10 is not equal to 10. 10, right, is not equal to 10. So what kind of statement is it? So to understand it, first of all, let's consider 10 is equal to 10. 10 is equal to 10 is true, right? 10 is not equal to 10 is obviously false. Is obviously false. That's why we have a false value here. So dear students, again, you need to practice by using all these comparison operators, and only then you can get clear understanding about actually logic which is used here. Okay, so another thing is that so in the output we may have only two values. The first value is false, right, as you already noticed it, and the second value is true. So we have only two values, false or true, right? So for computations is not that useful. Why? Because it returns as a text, right? False and true are some words. More useful for computing to have numbers here. So therefore, I will now teach you how we can modify, how we can change these formulas in order to receive some numbers. So actually, I will give you one term here, binary digits. So binary digits. So what does it mean? In a binary system, we have only two digits. What kind of digits? We have 0, right, as shown here, and we have 1, right? So two digits only. We don't have 2 here. We don't have 3. We don't have -1. So numbers in binary system, they can be written as 1, 0, 1, 0, for example. Okay, this is a binary system or binary representation. Binary system. Binary number system is very important. Why? Because computers are quickly understanding this. So if there is a signal, you can say 1. If there is no signal, you can say 0, right? We have only two digits. So it's very useful for using computers.
Throughout history, almost every civilization has used a decimal number system with 10 digits, 0 through 9. All of the numbers we can possibly think of use some combination of those 10 digits. Computers, however, operate very differently. Instead, they use a number system that has just 2 digits, 1 and 0. This system is called binary, and your computer uses it all the time. Computers need information in order to do what they do. This digital information, or data, is made up of something called bits. Bit is short for binary digit, meaning each bit is really just a single number, either a 1 or a 0. These bits can be combined to create larger units like bytes, megabytes, and so on that we use to measure our files. The larger a file is, the more bits it has. So something like a high-resolution video is actually made up of millions and millions and millions of ones and zeros. So how exactly do these ones and zeros come together and allow a computer to function? Let's think of binary as a light switch. Imagine that a 1 represents the light switch being on, and 0 represents it being off. With binary, the light is either on or off with no other possible states. So these bits are strung together as different combinations of 1s and 0s, and they form a kind of code. Your computer then rapidly processes this code and translates it into data, telling it what to do. You might be wondering, why do computers use binary instead of the decimal system that we use for counting things in the real world? Well, as previously mentioned, binary has two states, off and on. If computers were to use decimal, there would be 10 states instead. Our computers would have to work a lot harder to process all of these. Binary is easier for them to process and also takes up less space. Just like atoms make up everything around us in the real world, everything in the digital world, including video, text, pictures, and more, can be broken down into binary. And even though we can't see them, it's all a bunch of ones and zeros.
If you want to learn more about binary number system, I suggest you to read Wikipedia page in Korean language. So here you will find some good examples. For instance, for example, 100, we cannot read this as 100, it's not 100. Why? Because here we use a binary number system. Binary system has only two digits, 0 and 1. So if you see something like this, you cannot say that this is 100. Instead, it's better to write it in slightly different way. For example, 1, 0, 0 in binary system. So 2 means this system has only two digits, 0 and 1. So this is binary system, and this is decimal system. Decimal system. So as you know, in decimal system we use 10 digits. So 10 digits. What kind of digits do we use? We use 0, 1, 2, 3 until 9, right? So totally we have 10 digits, right? In binary system we have only two digits, 0 and 1. So totally we have 2 digits. There are some special rules you will follow to, for instance, add binary numbers or subtract binary numbers as shown here. So we need to follow some rules which are applied to binary system. So here you will have only two digits, again 0 and 1. So this system is very useful if you want to implement it on computers. So computers can understand it very, very well. So how in Microsoft Excel we can return 1 and 0 instead of returning true and false. So we will use a very interesting trick. So we will modify the formula as shown here, okay, and also here. So we will write our logical expression in parentheses. So I will use parentheses. Then I will multiply it by 1. So let's try to do this together. So we will multiply the expression by 1. Okay. So the input is still the same, so we have 10 here, and here I will modify it now. So I'm going to use parentheses. I think you understand what are parentheses. And I will close parentheses, then multiply by 1. Okay, I will multiply by 1. Then enter. So as a result, you will have 0 here, right? 0. Let me modify it a little bit. I will use greater than 10. Okay, so we have 0. So what does 0 mean? So let's check it out. So now I'm comparing A1, right? A1 with 10. A1 is equal to 10, right? So I want to check the following logical expression. 10 is greater than 10. So to understand what kind of expression is it, true or false, then we need to write in this way. So 10 is equal to 10, right? So it's true, right? In our case, what do we have? We have false, right? False. And if you multiply by, actually by 1, you will get false, which is 0, and so true will be equal to 1, okay? So please don't forget what is false and what is true. I think is also important. So if you modify it now, for instance, instead of 10, you'll write, let's say, 11, then you will get 1. 1 is true, right? 1 is, again, 1 and 0 are binary digits, so they belong to binary number system. Okay. So now let me show you one more example of how we represent numbers in a binary system and how we can convert them to a decimal system. Decimal system, as you again remember, in a decimal system we have 10 digits starting from 0 until 9, right? In binary system, we have only 2 digits, 0 and 1. Okay, suppose that the following number is written as shown here. So this is the given number in a binary system. So 1, 0, 1, 1, 0, 0, 1. Okay? So how to convert it to a decimal system? How to convert it to a decimal system? So it's very interesting. So what do we need to do here? What do we need to do, dear students? First of all, you need to understand what is 1 here. What is 1? Please look at this table. So this table is useful. So 1 should be multiplied by 2 to the power of 0. Okay, 1 should be multiplied by 2 to the power of 0. And we do so, right? So we take this 1, right, and multiply it by 2 to the power of 0. To the power of 0 is equal to 1, right? Is equal to 1. 1 multiplied by 1, okay? So we start from right and then go to the left. Right. We start from right, okay, and go to the left, okay, okay. Then the second one is 0 multiplied by 2 to the power of 1. It will give us 0, so we don't write it. The next one is 0 times 2 to the power of 2. It will give us 0, right? Then the next digit. So 1 times 2 to the power of 3, or 1 times 8. Actually, you can find it here, right? So we don't need to write zeros because they are equal to 0. The next one. So 1 times 2 to the power of 4. 1 times 16. Okay, you can find it here, right? And the next one is 0. And the next one is 2 to the power of 6. 1 times 2 to the power of 6 is 64. Will give us 64, right? And if you add this 64, 16, 8, and 1, you will get 89. So the number 10110001 in a binary system, so here we use 2 in subscript. So this is subscript again. I already told you this term, subscript. Subscript is equal to 89 in what? In a decimal system. So when we use decimal system, actually we also can write 10 here so that you will clearly understand that this is a decimal system. Okay? So this is how we convert from a binary system to a decimal system. Also, in Microsoft Excel, you can easily convert between different number systems. Especially we are interested in decimal system because we use decimal numbers, and also we want to know more about binary system because this system is well understood and of course used in computers. And also in electronics, they also use binary system. So in Excel, you will find a good function. So the function named is dec to bin, from decimal to binary. So it has one argument, as you can see here. So now I want to convert 10. So 10 is in decimal system, right? So if it's binary system, I won't say 10. I will say 10 in a binary system. But now it's 10. So then I will write it like shown here and enter. So 10 in a binary system is written as 1012. So we can say that so 10 in decimal system is equal to 1010 in binary system. So again, you will write this in so you can use the table from my presentation on how to convert it to a decimal system. So you will you will start from right. 0 times what? 2 to the power of 0, right? The first one. Then, okay, it's done. The next one. So 1 times what? 2 to the power of 1. Okay, it's done. 1. Then plus the next one is 0. 0 times 2 to the power of 2, right? Then the next one is what? 1 times 2 to the power of 3, right? You see that the powers are increasing. From 0, the superscript is changing. 0, 1, 2, 3, and etc. So here we have only 4 digits. So these are equal to 0. This is also 0, right? Then what do we have? We have 1 times 2 to the power of 3, right? So 8. 8 plus 1 times 2 plus 2 is equal to 10, right? 10. So the result is correct. So if you don't like such kind of computations, I think you can easily use so dec to bin function. I think it's very useful. So now let's create a small table and convert numbers from 1 to 10 to binary number system. Okay, I will just erase everything here. Okay, so I will create it here. So here will be decimal numbers or decimal number, simply decimal, and here binary numbers. So decimal means 10 digits are used, 0, 1, 2, 3 until 9. And in binary we have only 2 digits, 0 and 1, right? 0 and 1. Okay. So I'll use number from 0 to 10. From 0 to 10. Okay. I'm using Control and pressing mouse button here. So again, if you want to increase the number by 1, you will select the first cell, then just bring your mouse here until you see cross. Then hold Control. You will hold Control, you will press Control, and you will drag it down until you reach 10, right? Okay, 9 and 10. Okay, that's enough for me. Okay, then I will center it. I will center, and I will use borders here, all borders. Okay, So now let me use these functions. So equal. So I want to convert from decimal numbers to binary numbers. Decimal to binary. Binary, right? So instead of typing number as in the previous case, as here, I will simply use a reference to a cell. So I don't want to use absolute references, because if you copy it, then the reference will not change. So I need to use relative references. So I will select cell D3. Okay. Then I will simply close the parentheses and press enter. Okay. Then what happens then? So I will simply copy it to another cells. Okay. Now you can see that we have converted decimal numbers to binary numbers. So 0 is 0 in binary system, 1 is also 1, 2 is equal to 1, 0. 1, 0. Why? Because 1, 0, right? 1, 0, what does it mean? So 0 times 2 to the power of 0, right? And here we use plus, right? 1 times what? 2 to the power of 1, right? So we will have 0 here and we will have 2, right? This is 2 and so on. So when decimal numbers are increasing, then we will have more number of digits in our binary numbers. Again, if you see 1, 0, 0, 1, so before you read this number, I suggest you to think what kind of number system is used here. So better to write 2 here in a subscript, so that another engineer will understand that this is a binary system, but nothing else. So if you write this in a subscript, then engineer will read this as 1010, not 1010, okay? Not 1010, but if you write it in this way, 1, okay, and number system is 10, then I can read it as 1010, because this is the decimal system and this is the binary system. So please don't forget this, dear students. So, dear students, we can apply the same to numbers which have a comma, right? So not exactly integer numbers, right? But also numbers which have decimal places, right? On the right-hand side of comma. So now you will learn how to convert from a decimal system to a binary system. So in this case, I'm going to show you a very short tutorial.
Let's see if we can get some experience converting from a decimal representation to a binary representation. And let's start with a fairly straightforward example with a fairly low number. Let's see if we can convert the number 13 in decimal to binary. And I encourage you to pause the video and try to work through it out on your own. So I'm assuming you've had a go at it. So the key here is to see if you can deconstruct the number 13 as the sum of powers of 2. And then it becomes very straightforward to represent it in binary. Because in binary, you're essentially saying, well, what powers of 2 do you need to make up this number? And so let's just write the powers of 2 here, just to remind ourselves. And I'll go until we go right above 13. So 2 to the 0 is equal to 1. 2 to the first is equal to 2. 2 squared is equal to 4. 2 to the third is equal to 8. 2 to the fourth is equal to 16. And now I'm above 13. So I'm definitely, I have all the powers of 2 that I need to construct 13. So what's the largest power of 2 that is less than or equal to 13? Well, 16 is too large. Well, it would be 8. So I could rewrite 13 as 8 plus 5. Now 5 is not a power of 2, so I have to keep deconstructing that. What's the largest power of 2 that is less than or equal to 5? We see it right over here. It's 4. So let me rewrite that. It's 8 plus, instead of writing 5, I'll write 4 plus 1. And then the good thing is, 1 as a power of 2, we already see the largest power of 2 that's less than or equal to it is 1. This already is a power of 2. So I've now rewritten this as the sum of powers of 2. Notice this is 2 to the third. Whoops. This is 2 to the third power. This is 2 squared. And this is 2 to the 0 power. Or I could write it like this. I have 1, 8. I have 1, 8 clearly. I have 1, 4. 1, 4. And I have 1, 1. So I could add these these 3 together. 13 could be considered 1, 8 plus 1, 4 plus 1, 1. Well, why is that helpful? Well, now let's go into binary mode and think about what each of the place values represent. So this is the ones place. That's the ones place. And then we could go to the twos place. Twos place. Every time we go to the left, each place we multiply by 2. It's the next power of 2. Then we go to the fours place. Fours place. And then we go to the eights place. Eights place. Eights. And in binary, I only have 2 digits, 0 or 1. So I either have 0 of a place or I have 1 of it. So let's go through it. How many 1s do I have? Well, I have 1, 1. So I write that there. How many 2s do I have? Well, in this representation, I don't have any 2s. The way I've written, I have an 8, I have a 4, and a 1. So I'm going to put, I have 0 2s. How many 4s do I have? Well, I have 1, 4. 1, 4. And how many 8s do I have? Well, I have 1, 8. So 13, the 13 written in decimal, or 13, which is a decimal number, if I were to write it in binary, is 1101.
So, dear students, now you have learned how to convert from binary numbers to decimal numbers, and from decimal numbers to binary numbers. Again, so if you want to do this in Microsoft Excel, it's very simple. So what you need to know is only 2 functions. So we have used the first function. So dec to bin means from decimal numbers to binary numbers, right? So now let's create another table. So in another table, I will convert from binary numbers to decimal numbers. So let me do it this way. I will copy this and I will copy this formula here. Okay, so now I will convert this to decimal numbers. Okay, I will use formula here and C2, enter. Okay, so instead of typing the same, I will use formulas. Okay, so now I want to convert from the binary number to decimal number. So what kind of function should I use? So I'll use function bin to dec. Okay, so actually we have some other functions here. Please don't confuse. We want to convert from binary number to a decimal number. So bin to dec, right? And here I will use a cell reference F3, right? I will use F3 here. Then please don't forget to close the parentheses and press enter button. Okay, so then what you need to do is to simply copy the formula, to drag it down here. Just bring your mouse to this corner, right, until it becomes black cross here. Okay, then drag it down, and that's all. This is the result. So you can see that these numbers are exactly the same. So in first case, in first example, I have converted from decimal to binary, and in the second example, I converted a binary number to a decimal number. So I hope you understand the concept. So, dear students, just a short summary about logical comparison operators. They evaluate to either true or false, right? If you multiply the expression by 1, you can convert this to 0 and 1. Okay, 0 and 1. So 0 is what? Is false, right? And 1 is true, right? So logical expression has the following syntax. So first of all, we need to use expression 1, right? Then logical operator, we can use greater than 1 or not equal to or any other logical operator. As I suggest you to check the corresponding page of my presentation, or greater or equal to or not equal to, right? And so on. And don't forget the second expression. Only then you can get the output, so two outputs, false and true, right? 0 or 1. So this is what I wanted to tell you about logical comparison operators. Okay, so next, dear students, we will go to another topic, which is actually more general. We call this Boolean functions. Boolean functions. Boolean functions. So I think it has the same pronunciation, Boolean. So if you don't understand the concept, I suggest you to read the Wikipedia page about Boolean logic, so you can find some explanations on how it's used and what kind of things, what kind of problems we work on here. So for example, A intersection B. So we need to firstly understand what is a mathematical set. So this is important concept. Let me write it here. So set. So set has actually several meanings, and one of them is related to mathematics.
The topic of sets is by far the simplest topic to grasp in mathematics, since we have to tackle just 3 simple questions. First, what are sets? Second, why do we need them? And last, how do we represent them? Let's tackle the first question in this video. What are sets? A set is basically a collection of things. Think about it. What if you were asked to make a list of all the things you can see? Of course, you can't write all the things, but some of the things you would mention are a tree, a cell phone, a puppy, people, and so on. And what if you were asked to write down a list of things you cannot see? You would probably write oxygen, heat, and so on. These are the things you cannot see. A set is a collection of elements, yes, but they have to be related in some way. Let us look at a few more examples to understand better. Try to list down all the cricket-playing nations you know of. I would probably have said India, England, Australia, Pakistan, and so on. Now try to list all the oceans you've heard of. If you didn't know, there are 5 oceans in the world: Pacific, Atlantic, Indian, Arctic, and Southern Ocean. Now here's an interesting question. Can we make a set of elements for all the questions you're asked for? The answer is no, not necessarily. What if we were asked to make a list of the good teachers we know? We cannot make a set here because my idea of a good tutor may be completely different from yours. Similarly, we cannot make a list of intelligent students we know. The word intelligent is not well defined. So remember, another important characteristic of sets is that the elements in it should be well defined. all the elements in a set should be related and well defined.
So in mathematics, a set is a collection of distinct elements. So for example, set of these figures as shown here. So how many elements do we have here? 1, 2, 3, 4, 5, 6, 7, 8 and 9 elements. So we can do some operations with sets. So we can, for example, intersect two sets, or we can find the union of sets. And also I will explain you how this is related to Boolean functions we use in Microsoft Excel. For example, here, so there are two sets, right? And we compute the intersection. So what is belonging to the first set and to the second set. And here we see the union. So we include everything from set 1 and from set 2. So sets are important concept, very fundamental concept in the field of mathematics and of course logic. So if you are interested in sets or subsets, for example here, right, shown here, then I suggest you to read this Wikipedia page. So this is a very important concept. So Boolean algebra deals with binary variables and logic operation. A Boolean function is described by an algebraic expression called Boolean expression, which consists only of binary variables, the constant 0 and 1, and the logic operation symbols. So please check here. This is the applications of Boolean algebra. Actually, you can find applications in computer engineering, especially in electronics and circuits. So you can find some Boolean algebra computations here. So also, of course, this is important to understand how various algorithms are working. So often we use such when we program. For example, if you want to learn to program in different languages, for example, C language or Java language or Python language or any other language, you need to understand the logic. So if you don't understand the logic, I think it will be very hard for you to learn programming. So in programming, we often use such kind of statements like if. You know what is if, right? If. Also, when we talk to each other, we often use if, right? Also, we use then, right? Then. Also, we use else. For example, you may ask each other, so what else? What else? What else did he say? And some other things like return and end as shown here. All right, so now, dear students, let me show you one interesting example of using a Boolean logic for marketers. So here, as you can see here, you can see some shoes, right? I think you often buy shoes. You visit such websites like Gmarket or Coupang. And here, for example, you can find shoes, right? So there are two sets of shoes. Recently, I have explained to you what is a set. A set is a collection of some distinct elements. So here we have two sets, right? Two sets, let's see. One set and the second set, right? The second set. And here we have an intersection. Actually, this is the meaning of AND function. This is AND function, okay? So if you use AND function, you can find those things which exist in the first set and in the second set, okay? The next one is OR function. OR function. So here, if you apply it to two sets, both of these shoes will be included. Okay? So if you say not, right, is something which is outside of these sets. Not. For example, let's say you say, for example, today is cold. I would say that today is not cold. So it's something outside of being cold. It's warm, right? So I will show you some examples you can better understand the Boolean logic.